Today we're going to be looking at solving inequalities by adding, subtracting, multiplying, or dividing. When we add or subtract numbers to both sides of an inequality, it's exactly, when it's adding and subtracting, it's exactly like equations. They're treated the same. So for instance here, 3 is less than 5. And if I add 2 to both sides, I will get a true statement, an equation that's equivalent to this, that 5 is less than 7. It's less than 7 by 2, just like 3 is less than 5 by 2. For here, if I subtract 1 from both sides, I end up with 5 is greater than 1, which is proportional to 6 is greater than 2 by 4. Same thing if I add 3 to both sides, if it's in less than or equal to, and same thing when I subtract 4. So when we go to solve this, we're going to solve it just like we would an equation. And like I said, there's one exception, but that is not with addition and subtraction. So if we go through and look at these, I'm going to add 10 to both sides because that's like a negative 10, so I can get A alone. And when I do that, negative 10 and 10 is 0. So by the additive identity, A plus 0 is equal to A. And then over on the left side, or the right side, I'm sorry, 10 plus negative 3 is 7. So A has to be greater than or equal to 7 for it to work in here. So any value of A that is greater than or equal to 7 would fit in this inequality and make it a true statement. So we can always plug any number back in to check and make sure it's true. So for instance, let's say I'll put 10 in because 10's in the shaded region. 10 minus 10 is 0. And 0 is greater than or equal to negative 3. If I put in 7, 7 minus 10 is exactly negative 3, and negative 3 is equal to negative 3. So that works too. And this just reminds us to use closed circles when it's greater than or equal to or less than or equal to. And again, substitution, which is what I just did. Okay, so here we want to get D alone. We have 11 added to it, so we're going to subtract 11 from both sides. We do that, we get D is greater than negative 5. So we put an open circle on negative 5 and shade everything greater to the right. And I accidentally checked it before I shaded there. So pick 0. You can pick any number that would work. Of course, negative 5 won't work because it's an open circle, but I just picked something easy, like 0. Plug it in there. 0 plus 11 is 11, it's greater than 6. Here I'd subtract 12 from both sides. And it's not working. What's going on here? Okay, of course, freezing it. Okay, there we go. Okay, so we're subtracting 12 from both sides. And so B is less than or equal to 7. That's going to be a closed circle on 7 and everything to the left. And so if you pick 6, 6 plus 12 is 18, which is less than or equal to 19. Now here's where it changes, okay? And we're going to look down here at 8 is greater than 6. Now if I multiply a positive number, we're doing multiplication and division now, on both sides, I'm still good. So if I multiply 8 by 2, that's like saying 8 plus 8 is 16. And then 6 times 2 is 6 plus 6, which is 12. And you get a true statement. 16 is greater than 12 by 4 there. Same thing if I multiply or divide both sides by any number. Here I'm going to use a 2. Negative 5 is less than or equal to 7. It's a true statement just like above. Now over here, when I use a negative number, if I multiply both sides by negative 3, what happens is negative 3 times 3 is negative 9, and negative 3 times negative 2 is positive 6. And my inequality has to change because negative 9 is less than or equal to 6. And that's my dog. And so you have to flip the symbol when you multiply or divide by a negative number on both sides of an inequality. So here if I divide both sides by negative 9, I've got to flip from less than to greater than. Because when I divide, negative 9 divided by negative 9 is positive 1, and 18 divided by negative 9 is negative 2, and 1 is greater than negative 2. Okay, so if I go to solve, and I apologize for the noise out there, okay, I've got C divided by 4. I want to get C alone, so I have to do the opposite and multiply both sides by 4. So when I multiply both sides by 4, the 4 over 1, the 4's cancel or they divide out. So by the multiplicative identity property, 1 times c is c alone. Over here, 4 times negative 4 is negative 16. Hey, Tollway! Tollway! I'm teaching a lesson. Could you all be quiet, please? Okay, so c less than or equal to negative 16, close circle on negative 16, everything to the left. And I can pick a number. I'm going to pick something easy, like negative 20. If I do negative 20 divided by 4, I get negative 5, and negative 5 is less than or equal to negative 16. No, it's not. What am I doing wrong here? Okay, so if I pick less than or equal to negative 16, like negative 20 is less, negative 20 divided by positive 4 is negative 5, and negative 5 is greater. What am I doing here? What did I do wrong? Oh, I'm plugging it back in up here. I'm sorry, I plugged it in down here. Okay, so if I looked here and divided negative 20 by 4, and then I looked down at 16. But negative 5 is less than negative 4. All right, so got a little sidetrack there with my son. Sorry about that. Okay, so when you're checking, pick an easy number, something that works as easy. So here, when I multiply both sides by negative 4, okay, I got a bad, okay, there we go. All right, so then my negative 4's divide out, but it's negative I'm multiplying. So you got to hear that warning. That was a good little warning there. I got to flip the symbol. And so when I flip the symbol, that becomes less than, because I know that if I multiply or divide both sides by negative, well, I'm getting a lot of it there. Okay, so I get negative 1.2. T is less than or equal to negative 1.2. What's going on? This is not funny. Okay. So less than negative 1.2, there would be, that would not be negative 1.2. Negative 1.2 would be right here. I'm not sure what I was doing there. Okay, but it's everything to the left of negative 1.2, which is right here, not right here. Okay, so if I pick, let's pick something less than negative 1.2. I'm going to pick something easy like negative 8. That is in there. Okay, so if I pick negative 8, I think I'm, what is going on? I don't know why it keeps making that noise. Okay, so if I pick negative 8, put it in there, negative divided by negative is positive 2, and positive 2 is greater than 3/10, so that works. Alright, so then if we divide both sides here by negative 17, because I want to get b alone. Now when I divide, I have to flip this symbol, because I'm dividing by a negative. So that gives me 1b, and then 85 divided by negative 17 is negative 5. So when I do, I got to read it backwards. B is less than negative 5. That means here's negative 5, and I got to go to the left. So when I check it, if I pick something easy like, what am I picking? Negative 6. Okay, if I pick negative 6 times negative 17 is positive 102, which is greater than 85. And we're done.